So let's start with portable and well specified. What did we have to face? Okay, we need to somehow manage the VM instances if we want to build an application server. It's not running out of the box. No, we talked about it. And I think Ben said, if you have a server, you can probably set these parameters. No, we can't. I just had a mail again, and we are struggling for 2 years now, for example, to find the right set of VM parameters for 8, 9 different operating systems. Big problem. And nobody understands the implications. And you get a new release, oh, the garbage collector changed, so all these fine-tuned things are gone now, are working totally different. So, big problem. Also, the runtime itself simply behaves pretty differently on the different platforms, which is, in the end, crucial point. This can be, I have a 1 second response time, or I have a 25-second response time on the same application, other platform. Security. Yes, there are a lot of mechanisms built in, but most people don't know it, don't use it. So all the resources are exposed. And yes, it was this big promise. More people can work on that core of the application server. More people, less experienced people, they start to do pretty dumb stuff. Performance, yes, it's great. We have threads now. But as Doug said very clearly, and I totally agree, there are only very few people who can do that. The JIT is needed heavily, but we are struggling with instabilities. It's nice if it's working. It's nice if we can prove it's stable. All this. Reality is, yes, it's working on one platform, but
so
three others.
Unstable, it generates the wrong code, or?
In the end, I don't know if it generates wrong code because we don't catch it so easily, but it often leads to simply crashing VMs.
Okay.
That's pretty wrong.
Yeah, it's wrong.
So it might not be the
No, there are wronger things.
No, that's actually the best.
So
That's an order. You need to interrupt me. So it's simply dumping a little bit of the experiences of.
So we've seen issues where the JIT accelerates the code unevenly, and the Java app has race conditions in it that are only exposed when the JIT's turned on, or only exposed when you use a higher level of optimization, because you get variant accelerations. And so now race conditions get exposed, and the JIT's to blame.
Actually, I was referring to other stuff. That the application was to blame, but that we had, I don't know how many fixes in 4 months from Sun on the JIT compiler, which simply led to memory corruptions inside of the VM, not in the application. As I said, I don't know even how many bugs of that kind we have in the application, perhaps hidden because we didn't trigger. A crashing VM is very visible. Corrupted memory, wrongly behaving applications aren't as visible. We had that stuff, for example, that somebody said we have a regression after fixing some stuff. We realized before the application never went through. So it was fast.
So is any adaptive nature of anything an issue in your environment?
Sorry?
Of the entire virtual execution environment being adaptive, where things are changing.
Yes, sure. For example, one of the big problems the JIT compiler has with the application server and our applications is that we have a pretty complex class loading scheme, which we use. Loading applications on the fly. And this is apparently the way it's done is stressing the VM pretty much. And one thing we also discussed already is that really the garbage collector leads to pretty unpredictable response times. It's really memory use is one of the biggest problems we have. And the behavior of the garbage collector caused by this. Yeah, so memory management.
How big are your heaps?
Normally bigger than a gig, but less than 2 gigs because it's running mainly on Windows. Most of the test machines are Windows, so we are limited here. We are running against that limit, but it's the normal space we are running, 1 to 1.5 gig. Actually, for me, coming from operating systems, application server, core, written mainly in C, it was a big surprise to see after the notion, okay, you don't have any memory leaks. And this is the biggest problem. So really, this notion for the people, oh, it's solved, you don't have to care, leads to a lot of problems, which is really exacerbated by the lack of monitoring, the lack of alerting. So for us, especially running an application, it's very important simply to get notified early enough. You're running out of memory. There are no means so far. So Doug promised with 105 it will be better, but we have to get 105 on all platforms first thing. Okay, and we had the point about tools. It was also mentioned that there are great tools. Yes, there are. Definitely. There are ways to do stuff which are not, I've never seen before. But most of them are not production ready. So what we see is like profilers. It's like I know from the native world. It's an application server is blowing that up. So it's simply not right. It's very specialized. There are always people are struggling with that. So there is the potential, but they are not there yet. Would like to look at that from another angle, these problems we are seeing. So before I said we had this physical environment and the virtual environment. And we had the border in between, and we are missing that border. And this is going where Doug also was going in the direction like trust levels on code and separation of it is very, very important from my point of view and our experience. We need to have ways to say, okay, this is core server. And I have very different trust levels on the engineers in my groups. Like the runtime team is very small and dedicated, and I trust them very much. And even the guys, let's say, building the EJB container, I don't have so much trust. Due to this lack of border, people tend to overestimate this. Like with the concurrencies, like everybody is building, oh, I'm building my small cache, and it blows up to 1 gigabyte. Of course, there is no control. Then another thing we learned hard over a lot of years is never assume some part is perfect. Perhaps if it's going